and y equals to minus, we put minus 3 in, so I have 2 square minus 3, and I have y will be minus 7. Okay, and now I will have the coordinate is minus 3 and minus 7. And then the ending point of this this function of the domain will be x equal to 0. So when x equals to 0, y is minus 1 minus 3, which is minus 4. So the ending point is 0 and minus 4. Now let's draw the graph. Okay, y, and starting point is minus 3. See here, minus 3, minus 7, somewhere there. And the ending point is 0 and minus 4, which is also your y intercept. And now we have to draw a problem. The turning point is minus 1 and minus 3. Okay, so let's say here the turning point. Now we draw a parabola to connect them together. So because we used because the domain is in a square bracket, and that means both the starting and the finishing end of the graph is included. So we use a dark color, dark full circle, okay, to represent it. And now we have to label the graph. Y equals to minus x plus 1 square minus 3, and the domain is x belongs to square bracket minus 3 from minus 3 to 0. Okay. Now let's do a similar question with cubic equations. Okay. So let me rewrite the equation. Y equals to square x minus 1 cube plus 8, and the domain is x belongs to from minus 2 to 3, and both ending points are not included because of the circle bracket there. Now let's find the point of inflection, which is 1 and 8. Okay, we find it out by the similar way of finding the turning point, and let's look at the equation. The equation should have a shape like this. Okay, because there's no minus sign in the front, so the cubic equation should look like that. Let's find the starting point. When x equals to minus 2, y should be equals to minus 3 cube plus 8, which is minus 27 plus 8, which is 19, minus 19. And when x equals to 1, when x equals to 3, y will be 3 minus 2 is 2 cube plus 8, which is 16. Okay, so the points are minus 2 and 19. The coordinates are also 3 and 16. Now let's sketch the graph. And I have x, y. Start from minus 2, minus 19, minus 2, minus 19. Okay, sorry. Because the point is not included, okay, I have to use a open circle to represent it. Okay, and the other point is 3, 16. So let's put it here. 3, 16. The point of inflation is 1 and 8. There. This is the point of inflection. Point of inflation. Okay, so the graph would looks like that. And from the graph, we can say there is one x-intercepts and one y-intercept. We have to find them out. The x-intercept is when y equals to 0, and we have 0 equals to x minus 1 plus 8. Sorry, when y is 0, we have this function, this equation, and well, let's rearrange it. Equals to minus 8, and x minus 1 equals to minus 2, and x will be minus 1. So x-intercept is minus 1. And we assume x equal to 0 for y-intercepts, which is 8. Which is minus 1 cube plus 8 and 7. Okay, so this point here is 7. Now we label the graph y equals to x minus 1 cube plus 8, and x belongs to, the domain is from 1 to 8 with open bracket. Okay, now let's look at question E. Question E is a cubic function, and by looking at it, we have to find out its factor by long division, and the domain is from minus 10 to 10. Both points are not included, and the shape of the graph should be this one. Because of the minus sign, it should have this shape. Okay, now let's start factorizing the graph, the function. Let's assume the factor is x minus 1. Let's assume it first. So we need to substitute x equals to 1 to find the remainder. Okay, make x minus 1 equal to 0, and we have x equals 1. We assume this, and we substitute this in the function to find the remainder, to check if it is 0. Okay, the remainder is minus 1 cube plus 7 minus